everyone, it's Alyssa and welcome to You Can Learn Math.
Today we're talking about multiplying radicals. Now, before I go another step, I want to know, do you know how to simplify radicals? Do you? If the answer is no, I don't, or even I think I remember how to do that, please, 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 please go watch the video linked down below first that talks about how to simplify radicals. You have to know how to do that and be very good at it before you can multiply them and get the right answer. I'm just saying. All right, so multiplying radicals. There are a couple of things we're going to look for in every single one of these. We are going to see if the radicals that we are multiplying have the same degree out here. So in this case, these are both square roots. They match. They are the same. If this one was a cube root, they would not match and you could not multiply them. That is always the first thing you want to look for. Do these two match? If this was also a cube root, then you'd be fine, right? The next thing you're going to know, or you're going to need to know for this, is that once you've determined that they match, you can combine them under a single radical. So the square root of 4 times the square root of 5 is the same as the square root of 4 times 5. And you can go either direction. You can take this and split it up, or you can take this and combine it. Both of those things will be helpful depending on the problem. Last but certainly not least, after you have done this, in this case, 4 times 5 is 20. And you're like, yay, I've multiplied them. Yes, but you do not have the right answer yet. You have to simplify the radical. Hence the reason I said go watch that video first. Because if you do not simplify the radical at the end, your teacher will mark it wrong. Okay, so let's do some examples. First one is going to be just plain numbers. Second, we're going to add some variables. And third, we're going to do a FOIL, we're multiplying binomials, and show you how that works when we're multiplying radicals, because you're likely to see all three types of this. Right, so first one, if I have something like this, where they are just regular old numbers, there's no variables, there's nothing funky going on, it's just those numbers. Your teacher or your math book is likely to say, multiply the radicals first, then multiply the numbers and combine. That can be a little bit vague, honestly, that wording. So what that means is -5 square root of 10 is the same as -5 times the square root of 10. And 2 times square root of 15 is the same as 2 times the square root of 15. Now, fancy word incoming, the commutative property of multiplication says we can reorder things when we multiply. So that means I can swap these two and write it as -5 times 2 times the square root of 10 times the square root of 15. So now, hey, I can multiply -5 times -2, and that gives me -10. And as we've just said, these both have the same radical. They are both square roots. So I can rewrite this as square root of 10 times 15. Okay, so next step, -10 times 10 times 15 is 150. Now I've just got a single number and I have a single square root. Am I done altogether? No, I haven't checked to see if it's simple. I need to simplify it. Can square root of 150 be simplified? Yes. It is divisible by 25, which is a perfect square. So square root of 25 is 5, and I'm going to bring that outside. And 150 divided by 25 is 6. It leaves 6 behind under the radical. Again, if that does not ring any bells, please watch the video on simplifying square roots. I can't say that enough. I just can't. Right, and finally, now we have our -10 and our 5 are both outside, so I can multiply those together to get a -50, and the square root of 6 just stays as is, and I'm done. This is at the simplest form, and all the numbers outside have been combined. So let's do one that includes some variables in there. So this is going to be 3 times the cube root of 5a to the 4th. And I'm multiplying this by the cube root of 10a cubed. Now here's something too. If you're a person that you want to see about simplifying beforehand, like, oh, I could simplify this with a cube root, and you want to do that first before you start combining things, there's nothing wrong with that. You absolutely can do it that way. And same over here, like, oh, I could simplify that. You can do that. Order doesn't matter in this case. If your teacher has a specific order of steps they want you to follow their lead, but mathematically, it doesn't matter. The way I'm going to be doing it is combining everything first and then simplifying at the end. But if you're asking, can I simplify first? Yes, you can. Just double check and make sure it doesn't need more simplifying at the end, because that may come back and bite you. Right, so first things first, do these both have the same radical there? Yes, they do. They are both cube roots, so I am good to go. There's no number sitting out front here. There's just this 3. So I'm going to leave the little 3 off to the side by itself, and I'm going to worry about multiplying these together. So it's all going to be under the cube root of 5a to the 4th times 10a cubed. And I just multiply them just like I would any other time in algebra. 5 times 10 is 50. A to the 4th times a cubed is a to the 7th. Now, same sort of thing. Can I simplify this? Is there a cube root of 50? You go, cube roots can be a little tricky. One way to do this is you do a factor tree. If you're not familiar with factor trees, another link down below. And I would say, okay, so 50 is 2 times 5 times 5. Those are the prime factors of it. And I do not see a set of 3 matching numbers. There's a square root in there because there's a set of 2 matching numbers, but there's no set of 3 matching numbers amongst these factors. So there is no cube root hiding, or excuse me, there is no perfect cube hiding in 50. So it has to stay under the radical. I can't bring it out. A to the 7th, though, when we're taking roots of variables with exponents, quick reminder, we divide by the root, and what we get as the quotient, the answer, is going to come out and the remainder stays in. So what that means here is a to the 7th is 7 divisible by 3. Yes, it is. 3 goes into 7 2 times, so a to the power of 2 comes out, and I have a remainder of 1. So a to the power of 1, or a, stays in. And as I said, that 50 stays in. So our final answer is 3a squared times the, don't forget that cubed, cube root of 50a. And I've done it. There's no further simplification. So the last one, which you're likely to see when you're being asked to multiply radicals, is where they take a set of binomials and they want you to multiply those together. So in this case, it's going to be negative 2 times the square root of 2p plus 5 times the square root of 5. And as always, I'm writing too big, and I'm going to have to zoom out to accommodate my massive handwriting on the screen because I can't write small to save my life, times the square root of 5p plus the square root of 5p. Now you're combining a couple of things. Hopefully you are recalling, like, hey, I remember FOIL or multiplying binomials. I remember how to do this. So I know my steps. If this is not sounding familiar and when I'm watching this it's confusing, please watch the long form video below. I go into this in more detail, how to multiply binomials. There's a lot of this. You're going to find this in algebra. It's so cumulative. They expect you to remember everything that you've done before, and you have to apply it just repeatedly. Just be aware it happens. So we're going to multiply our first terms. So that's negative 2 times the square root of 2p times the square root of 5p. And I'm going to put this in parentheses so we're very clear that we're keeping this separate and we're just multiplying those together first. Then our outside terms. So that's going to be negative 2 square root of 2p times square root of 5p. Then our inside terms. And that's going to be 5 square root of 5 times square root of 5p. And I'm running out of room. Who could have seen that coming? She says, ironically. All right. And then last, but certainly not least, we have our 5 square root of 5 times the square root of 5p. Hi, I know it's a lot. What you're going to do is you're going to do each one individually, like 4 separate little tiny problems, and then you're going to look for like terms at the end to see if you can combine. Sometimes you will, sometimes you won't. There really is no telling which way it's going to go. All right, our first one, -2 square root of 2p times square root of 5p. They are both square roots, so we can combine, and there is no number in front of here, so the -2 is not going to be multiplied by anything. It's just going to be by its little lonesome. Now the square root of 2p times square root of 5p, I can put those under the same radical, 2p times 5p, and I have -2 times the square root of 2 times 5 is 10, p times p is p squared. Can that be simplified? Are there any square root factors in 10? Nope. What about p squared? Yes, I can take the square root of p squared and it's just p, so that comes out. -2p times the square root of 10. That's one down. On to the second one. So -2 square root of 2p times square root of 5p. Well, that looks eerily familiar, doesn't it? So similar. It's not a bad idea to do it twice. If you're like, wait, I just did this, why do I have to do it again? If you have the time, it's not a bad idea to do it a second time. It's a way of catching mistakes. All right, so the -2 is by itself, nothing to multiply it by, so it just stands alone. The other two, 2p times 5p, I can combine together. So I'm left with, say, -2 times 2 times 5 is 10, p times p is p squared. Is there a square factor in 10? No, there isn't. Is there a factor of p squared, or can I take the square root of p squared? Yes, I can. It comes out to be -2p times the square root of 10. Did I get the same thing twice? Yes, I did. Thank goodness. Moving on to the third one, 5 square root of 5 times square root of 5p. Is there any number in front of this one? No, 5 doesn't have anything to be multiplied by. It stays alone. The other two, I can combine 5 times 5p, or 5 times the square root of 25p. Is there any factor of 25 that's a perfect square, or can I take the square root of 25? Yep, it's 5, which we could see because we just did it. It was 5 times 5. So the square root of 25 is 5. That comes out, and the p stays behind. So 5 times 5 is 25 square root of p. Final one, home stretch, and look, it's the exact same thing we just did. The 5 stands alone outside. It doesn't have anything to multiply itself by, so it stays by itself. The other two get combined together into 5 times 5p, or 5 times 5 is 25, and p. Can you take the square root of 25? Yes, you can. It comes out 5 times 5, square root of p, 25, square root of p. Okay, did I get the same answer twice? Yes, I did. Woo! The crowd goes wild. Now we have our 4 final answers. We have -2p square root of 10. Again, -2p square root of 10. Then 25 square root of p and 25 square root of p. And do not forget, these are all being added together. Now we're on the lookout for like terms. When we're talking about like terms, when it's variables, it's that they have to match, like say 5x plus 6x. Those x's are the same. If one of them is an x squared, you can't combine them. They have to match exactly. And then you can say I have 5 x's and 6 x's for a total of 11 x's. This same principle works here. If the radicals, we have here square root of 10, square root of 10, square root of p, and square root of p. Whenever those radicals match exactly, you can treat them like they're a variable. So here I have square root of 10 and square root of 10. I can treat them like variables. So I have -2p square roots of 10, and I add another -2p square roots of 10, and that gives me -4p square roots of 10, which we would say that is -4p times the square root of 10. Over here I have 25 square roots of p, and I add 25 more square roots of p. So I can combine those, treat them like variables, and it's 50 square roots of p. And there we have our final answer. I cannot combine anymore. There is no more simplifying to be done, so we are done.
I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.